3.7 Qualitative Graphs. Sarah walks from her home to the store. So she starts at her home and she's going to go to the store. Halfway to the store, she realizes she forgot to bring her money. So she returns around to return home, gets her money, and then walks all the way to the store. Graph time on the horizontal axes and distance from home on the vertical axes. So we don't have too much space, so I'm going to do the graph over here. So we're going to start by drawing an x and a y axis. Our focus is going to be in quadrant 1 because we're looking at a story. And it says that our horizontal axis is time, which makes sense. Time is independent. And then the distance she is from home is the y-axis. So you want to imagine that the x-axis is essentially representing her house. And as we move away from the x-axis, we're moving away from the house. So let's start drawing out this story. So she starts walking from home to the store. Halfway, she realizes she forgot her money. So she turns around and goes back, gets her money, and then walks to the store. So there's our graph. So it's going up, walking away from home, turns around, takes a moment to get her money at home, and then goes back to the store. Okay, next one, number 11. Let's go ahead and start with an x and a y axis. Rashid is jumping on a trampoline. Graph time on the horizontal axis and his distance off the ground. Distance off ground. Okay, so imagine the x-axis is the ground. So when you get on a trampoline, you're going to be above the ground already. And then when you're bouncing, you never touch the ground, right? You might get higher and higher. There we go. So these minimums should all be at the same level because that's his feet touching the trampoline. Yeah, the trampoline's going to dip a little bit, but hopefully the dip of the trampoline doesn't hit the ground. All right, number 12. Carlos lives in a large city and travels to school on a local bus that stops at every block to let passengers on and off. Graph time on the horizontal and speed on the y. Okay, so time and speed. Okay, so Carlos lives in a large city, travels on a local bus, stops at every block to let passengers on and off. Okay, so he gets on the bus. That's the starting time, right? And the bus is going to it's going to speed up. And then it's going to stop to get a passenger. And then it's going to, speed. So that's 0, right? Okay, so let me rethink about this. It's going to speed up, speed down, slow down, stop to get a passenger, speed up, speed down, get a passenger. So that's the speed that it's going. So maybe it only hits 30 miles an hour. But it's got to come back down to a stop, slow stop, stop to get a passenger, and then keep going. So there you go. All right, turn it over to the last page. These are going to be your you try problems. So you can go ahead and pause the video, try these, and then hit resume when you're ready to go over them. Okay, so number 1, roller coasters. The graph below shows the speed of a roller coaster during the first 30 seconds. Describe the change in speed over time. Okay, so it slowly goes up, and then it comes to a stop. So it's probably going up a hill. Okay, so speed increases slowly, but comes to a stop. Then, real quick, right? Takes off. So it's probably a drop in a hill, right? And then it kind of slows down again. And then it's slowly slowing down over time. All right, hiking, number 2. The graph below shows the altitude of a hiker during a hike. Describe the change in altitude over time. So it is a slow walk up a hill, and then it looks like that they get up really high really fast. This must be really steep. So starts off easy, slight hill, steep hill. That's the altitude, so it's going up real quick, right? Maybe steps, because that will take you up fast in a short amount of time. But then over time, the altitude stays the same, so it's a flat path. The altitude doesn't change. Okay, then maybe we have a couple more steps or something, or a big jump, steep hill or steps. Again, it's happening in a short amount of time, so that they're doing it quickly. Then it's another flat path. Then it's a quick way down, so steep hill again. Steep hill down, or maybe steps. Again, something to get them there quick. Then it's a flat path, because the altitude is going down the altitude is staying the same over time. And then again, another quick altitude drop. So again, another steep hill or steps going down. Okay, next, money. The graph below shows the amount of money in a soccer game's club account. Describe the change in balance over time. All right, so they start with an initial balance. Then it looks like they deposit money. And it stays like that for a little bit. Right, staying. Then looks like they are buying something. Big purchase. And then again, it stays the same. Okay, music. The graph below shows the tempo of a song as it is played. Describe the change in tempo over time. Okay, so we have a steady tempo. Tempo picks up. It's steady again. Tempo picks up even faster. Tempo stays. It's a steady tempo. Slows down. And then it's steady again. All right, last one. Exercise. Ryan monitored his heart rate while exercising. During the warm-up, his heart rate increased slowly. While exercising, his heart rate increased rapidly and then steadied. During cool down, his heart rate lowered quickly. Sketch a qualitative graph to represent. So we're going to have time and heart rate. So his heart rate isn't at 0 where he's dead, so it starts up a little bit, right? It increases slowly. Then it increases quickly, stays steady, drops quickly. There you go.